Hi guys, who knows a vegan? That's like all of you. There are 2.6 million medical marijuana users right now in the United States and only 1.6 million vegans. So medical marijuana is just bursting in popularity right now, and it's a really important issue that we should talk about. My paper is called THC-caused synaptic and memory impairments are mediated through COX-2 signaling, or in other words, negating the detrimental effects of THC to make medical marijuana safe. So what is medical marijuana? Just a couple of baseline points. It helps with things like pain, Parkinson's, Alzheimer's, and seizures. It's currently legal in 29 states and DC. And the chemical component that makes medical marijuana so effective at aiding in these ailments is CBD, not THC. CBD doesn't make you high, it just kind of relaxes you. And then it's taken through oils, smoking, vapor, and edibles. So before I delve into the paper, a couple big key terms is THC, which is the psychoactive component of medical marijuana that damages the synapses. COX-2 is a protein that's responsible for inflammation in the brain that can damage synapses. And then synapses is basically where two neurons connect and they send signals to each other. So the first thing that the scientists wanted to look at was THC's relationship with COX-2, because COX-2 is responsible for that inflammation in the brain, and that's what can really damage synapses. So in the graph on the left, they had two groups of wild-type mice. One group was administered nothing, and the next group was administered THC. And then 7 days after the administration of THC, COX-2 levels in both groups were measured. And the group that wasn't administered anything had a lower COX-2 level than the group that administered THC. So there's a direct correlation between THC and COX-2. And then on the right here, they wanted to see what this upregulation in COX-2 was being caused by directly. So what they did was they knocked out CB1R, which is cannabinoid receptor 1, which is just basically where THC binds in your brain. And they found, they had the same groups again. They had two groups of wild-type mice. One group wasn't administered anything. One group was administered THC, and they both had the same COX-2 levels when CB1R was knocked out. So from this, we can conclude that THC upregulates COX-2 via cannabinoid receptor 1. So next, they tested synaptic potential, which is basically a quantification of the amount of signaling going on between your synapses. And this is important because higher synaptic potential basically just means that you have better brain activity, you can learn better, more memory, things like that. So on the left here, I took wild-type mice, and then just focusing on the red and the green bars that are highlighted. In the red group, mice were just administered THC and they were wild-type, so they didn't have any inhibitors or anything like that. And then in the green group, right there, they were administered NS398 and THC, and NS398 is a COX-2 inhibitor. And as you can see, the synaptic potential, which is the y-axis, in the group that was administered the COX-2 inhibitor and THC was the same as the wild-type group with nothing given to them. So basically that inhibiting COX-2 was able to return their synaptic potential to normal. Then on the right, they basically did the same thing, except they just knocked out the COX-2 gene. And then when they knocked out the COX-2 gene and gave mice THC, synaptic potential was the same in that group and the wild-type group with nothing administered. So basically just building a pathway here. THC binds to CB1R, which activates COX-2, and then if you inhibit COX-2 with NS398 or COX-2 knockout, it will activate synaptic potential. This is just a double negative. That's groovy. That's what we want. So after we proved the kind of the molecular effects of this, they wanted to test it in a behavioral model. And the Morris water maze is just like a tub of water, and they place a mouse in it, and there's a little platform, and the platform is the only way that the mouse can breathe. So basically, the more time that the mice spend near the platform, the better we assume their learning and their memory are. And they'll actually put the mice in multiple times to see if they remember where the platform is. Any questions so far? I'm going to go too fast.
Can I just clarify? They can breathe, they just don't like swimming. Right? They breathe easier when they're not swimming, but they can breathe.
Anything else? So now that we have the same groups as we did before with the synaptic potential testing, and in this graph they're measuring the percent of the time that they spent near the platform. So the red bar there is a wild type mouse with THC administered, and they spent about 30% of the time near the platform, as opposed to the black bar, which is the wild type mouse with nothing administered, spent about 50% of the time near the platform. But then in the blue bar, we see that a mouse administered COX-2 inhibitor and THC, they spent about 50% of the time near the platform. So it was the same as a normal mouse. And then also the kind of burgundy bar is just a COX-2 knockout with THC. It's basically the same as the wild type. So basically we can conclude that COX-2 inhibition restores cognitive function that is taken away by THC, basically. Any questions? So next they wanted to test COX-2 inhibition in fear memory. So basically they had mice and they just shocked them in the feet like for a day. And then they measured the next day how much they were standing still in fear. And then in the THC group, the red bar right there, they only spent about 10% of the time in fear. So like they did not remember the foot shocks at all. But then in the blue bar, with COX-2 inhibition and THC, they spent about 30% of the time in fear. So basically, with the COX-2 inhibitor and THC, their memory was returned to normal, and they were able to remember like the feeling of the foot shocks and be scared. So just kind of adding to the pathway, THC binds to cannabinoid receptor 1, which activates COX-2. COX-2 inhibits synaptic potential, but when you inhibit COX-2, synaptic potential is restored to normal, and learning and memory are restored to normal as well. So I've talked about basically restoring your brain function to normal with THC via COX-2 inhibition, but we still need to look at the positive effects that THC has and medical marijuana has, even in the presence of COX-2. So these are brain scans. They had mice that had Alzheimer's. They had like plaques on their brain that are like Alzheimer's. In the top group there, you can see there's a lot of green. They basically had severe, like a large amount of plaques. But then when they were administered THC, there's a lot less green. So we can see that the THC does a really good job of taking away these plaques, but that's just THC alone, so it's still destroying your synapses. But on the bottom here, they use something called Celebrix, which is a COX-2 inhibitor with THC, and they saw that it had the same effect that just THC had. So COX-2 was not affecting any of the positive effects of THC, it was basically just taking away the negative. So basically, in conclusion, THC damages synaptic function via COX-2, and COX-2 inhibition restores synaptic integrity in the presence of THC. Memory, learning, and cognitive impairments brought on by THC were mediated or negated by COX-2 inhibition. And now for the future, if medical marijuana users are somehow given a COX-2 inhibitor in combination with their medical marijuana, we can help their brain, basically. Their brain won't suffer the synaptic damage, and their learning, their cognitive function, it will be restored to normal. Thank you. Any questions?
Can you go back to the slide that showed the beta plaques? So when it's measuring just the green is just staining the actual plaques.
It's staining the plaques, yeah.
So the THC was taking out, was like
yeah, the THC
dispersing the plaques?
No, it was destroying them, basically. They were getting smaller and smaller.
So could this be applied to like treatment of Alzheimer's if you see that the plaques?
Absolutely, that's kind of the point here, basically, is that THC can be like, it really helps in this, and then we kind of knew that it would, but then we just wanted to see if in combination with COX-2 inhibition, did THC still have like the positive effects.
What's the blue stain in this video?
I'm not sure what the blue stain is, so I'll get back to it. I think it's just pretty bad.
Did the researchers mention, or do you know what inhibition of COX-2 like long term might do? Are there other effects of
Basically,
inhibition?
when I did my research into just COX-2, there's not much of a role for it, like in a normal person. It's just they just see like in Parkinson's or things like that, in diseases that have the synaptic integrity compromised. COX-2 is just very prevalent. It's just an inflammation protein, and it just gets in the way of synapses basically. So I couldn't find anything that's like that makes COX-2 necessary for us in daily life, basically. Anything else? Thank you.
Hi, I'm Dylan. Next week I'm going to be presenting on Zika virus being used as a brain cancer treatment, specifically glioblastoma, so come around and support.